I just need to know if we're live right now. Yes, we are live. So, boys and girls, what's up? I hope everybody of you is doing great, nice, and absolutely fine. So, what's up, everybody? This is me, Yawar Manzoor, and I hope everybody of you is doing absolutely fine. Okay, do let me know in the live chat how many of you people are feeling so nice today. Come on, everybody. Hey, yo, sir, what's up? What's up? What's going on? Hello, hello, hello. Okay, do let me know in the live chat how are you guys feeling? Fine, not well. You can just write it over here. Okay, people are actually joining. Come on, come on. So, what's going on? I'll just read out some names over here from the chat itself. PES is live. Okay, Lakshmi, Manoj, nice, nice. So excited for your class, sir. That's very nice. I like it. Awesome, awesome. Okay, good, nice. So, what's going on? I hope everything is fine with you people. And today we are starting this basically Fury Live. We're gonna take it to the next level. Okay, for sure we're gonna take it to the next level, and you will definitely love it. Everybody will love it. Okay, love sir is in the chat itself. Take my name, love sir, the love legend. The love of all time. Okay, thank you sir. Sir, what's going on, sir? Sir, I already took your name, sir. Sir, आप तो हमारे गुरु हो. Okay, so what's going on, everybody? Waiting for your class. That's very nice. I like it. Okay. And we are starting the 11th portion by today itself. Tomorrow we'll be basically starting the 12th portion. So I suggest everybody to join all the lectures. Understand? Like we're coming up with the 6 lectures in a week. So all the people are requested to join all the 6 lectures. Then only they will would be able to crack the JEE mains in advance. Okay. So we are starting the kinematics. We'll be talking about what is distance. We'll be talking about what is displacement, speed, velocity, average velocity, instantaneous velocity, average speed, instantaneous speed, everything we're gonna covering in this lecture itself. And I'll be showing you, once we get done with the theoretical part, I'll be showing you the problems as well at the end. Okay, everybody, you made my day. Thank you, sir. Okay, so guys, let's move. Kinematics 1D. This is what we're gonna be talking about in this one. Starting, a lot of people were basically asking me to start from kinematics 1D. Okay, that's why I started this. Okay, soon Manoj. Okay, chalo. Yes, you will be getting the PDF. Okay, definitely you will be getting the PDF. I'll be putting up the PDF in Love Sir's Telegram channel. Okay, I want you people to join that channel only right now, and from tomorrow onwards I'll be putting up on my Telegram channel. Okay, fine. Okay, everybody. So this is a piece of information about me. My name is Yawar Manzoor, and I'm a JEE physics expert, and I am from all the way from Kashmir. Okay, that's a piece of heaven. I believe, I hope you also do. And I have got this much of experience, and I have taught so many kids and students till now. And we have this plus platform, and we have this iconic subscription. Means, see, right now I'm teaching you people on YouTube, but we have our own platform, that is the Unacademy's own platform, where you're gonna be seeing, if you join us over there, you will see different number of things like that are more exciting, that are more special. Like we have the polls over there in the special classes. You can have voice chat with your teacher itself. So that is definitely more fine than YouTube. Okay, from the learning perspective, I'm saying. Okay, everybody, sir, PDF, DPP, everything we're gonna be giving you guys. Okay, Harshvardhan. Okay, put in the description box. Yeah, we can do that as well. Yes, yes, yes. Yawar sir, Josh is high. Yes, yes, my Josh is high. What about you guys? Okay, tell me now. And I want everybody of you to like this session right now, right here, right now. Abhi ke abhi. And see, if you take this plus subscription, what you're gonna be getting is you'll be getting live classes every single day. Understand? There are lots and lots of educators who are teaching you on Unacademy every single day, and you'll be getting the structured courses. Structured courses means the courses which are designed in a well manner. Understand? The country's top educators have basically designed these beautiful courses for you people only. You will get the weekly tests. In order to crack any of the competitive exam, you must go with these weekly tests. It's very mandatory, okay? And this unlimited access, one of the beautiful features. That means you can watch anybody's lecture any damn time. Okay, excited as hell. That's what I love, okay? That's nice, sir. Are your male model eyes seen about you, sir? Yes, 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 yes. Okay, that's nice. And apart from this, we have the Iconic subscription as well. In this Iconic subscription, you're going to be getting everything what you get in the Plus. And there are some other benefits as well that you're going to be getting in this Iconic subscription. That is this personal guidance. You'll be getting a educator from the Unacademy that will definitely guide you till your exam. Once you crack your exam, if you have any sort of doubt, he'll take all the doubts out of your mind, and you'll be getting this test analysis. Understand? Once you give the test, after that you have to analyze where you are exactly lagging. Understand? In which portion you have to work more. That is basically the test analysis. You'll be getting the experts guidelines, study material, study planners. There are lots and lots of features you'll be getting on this Plus and Iconic. And most importantly, if you want to follow me, you can definitely follow me on Unacademy. Okay, this is my username over there. You can just type it and you can follow me over there by typing this username. And this is my username on Instagram as well, on Facebook as well, everywhere. Okay, if you want to join me, you want to basically talk to me about different things, you can definitely type this on any social media and you can have a conversation with me, definitely. Okay. East or West? Yawar sir is the West. Wanna come from Tamil Nadu. Thank you so much, buddy. Means a lot. Okay, okay, okay. Okay, okay. Okay, when will be the special class? Special classes will be from tomorrow onwards, okay? Special classes will be from tomorrow onwards. Okay, love from Gujarat means a lot, buddy. Okay, sir, will you take us? Sir, will take advanced level also be taught? Yeah. Okay, we have promised you people will be basically dealing with every damn thing, whatever comes in your JEE syllabus, okay? So no need to worry about that. And we have this Unacademy Iconic subscription. See, basically, Unacademy branded study material will be provided on purchase of 12, 18, and 24 months subscription. See, we have made the branded notes for the people who will take the Unacademy's IIT JEE Iconic subscription. Understand? So if you take it for 12 months, if you take it for 18 months, and if you take it for 24 months, then only you'll be getting those branded notes. Understand? That will not be in the PDF format. That's basically the hard copy. Understand? Everybody. So if you want to take this, so grab this offer right now, right here. Understand? And this is the Plus subscription offer over here. Understand? If you take this Plus subscription for 12 months, you'll be getting 2 months extension. And if you take this Plus subscription for 24 months, you'll be getting 2 months extension. Sorry. Understand? So you can grab this offer right now, right here. Everybody. Sir, for class 12, what chapter tomorrow? We'll be starting from the electrostatics, okay? But I suggest everybody to join this one also. All the people can join the class 12th lectures as well and class 11th lectures as well. Understand? Okay, because this is a Fury Live, okay? This is Fury Live. This is not like we are teaching you for JEE 2023 or we are teaching you for JEE 2022. This is in general. Everybody can watch any damn lecture because we're gonna be starting from the basics onwards. That's why. You will understand every damn thing. And we have this Plus subscription. Basically, you can take it for the 12 months. You can take this Plus subscription for 18 months and you can take this Plus subscription for 24 months. Okay. By using my code, you can get the maximum possible discount. This is my code, Yawar. And you will be getting it for 34,650 rupees for 12 months. Okay, and you can take it for 18 months as well. By using my code, you can get the maximum possible discount. You can get it for this much of price, understand? And here also you can get the maximum possible discount. And you can take this Iconic subscription for 12 months, 18 months and 24 months. The prices are basically given over here. You can just check it out. And by using my code Yawar, you can definitely get the maximum possible discount. So I suggest you to use my code only. Sir, one shot lecture. Yes, you'll be getting the one shot once we get done with all the lectures of the entire chapter. Okay, you'll be definitely getting the one shots as well. Okay. That's very nice. The Fury is back. Yes, the Fury is back. Definitely. Now class for 11th or 12th. This is for everybody, but we are starting with the 11th portion. Okay. Everybody can definitely join this one, and I suggest you to join this. Okay, and next we have this beautiful feature on Unacademy, Ask a Doubt. If you have any sort of doubt, you can definitely post a picture. You can take a picture, crop it and upload it on Unacademy. You will get the solution within no time. Okay, and these are the batches, upcoming batches which are running in Unacademy right now. These are the batches which are coming up, understand, very soon. So I suggest you to take any of these batches. Okay, this has already started on 4th August, 4th, and this will be starting on 11th, 18th. So if you are appearing for any of the JEE 2022 or 2023, you can definitely enroll over here because country's top educators are providing you the next level content. Sir, can we clear JEE mains by YouTube? This is the common question that every person asks to every single educator. I have been answering this from past, I don't know how, from past few months, okay? See, it completely depends upon you, bro. As if you ask me, sir, if we go with this Fury Live, will we be able to crack the JEE mains and advance from this one only if we learn from this only? I suggest you to go with some other material as well. Understand? I can show you for example, on a particular topic, I can show you 30, 40 problems. But if you want to crack the JEE advance, you have to you have to solve the unlimited number of problems. So that is mandatory. Understand? Okay, so you are awesome physics teacher. Yours is the coolest. Thank you. Means a lot, buddy. Okay. Chalo. Today's topic in this lecture, in this session, I want everybody of you to have the same josh, same energy like I have. Okay. Everybody show some love in the live chat. Do send me the hearts right now so that I'll get to know you people have the same energy like I do. Everybody, show some love. Send me some hearts. Send me some fire. I want to see. Okay. Okay, everybody, you have to be very furious. You have to be like Fury. Okay, you have to show unstoppable energy. Have to show next level energy. Then only we're gonna crack any damn exam, whatever is coming in our way. Everybody. Okay. Namaskar, sir, from Andhra Pradesh. That's very nice. Thank you. Okay. Yes. Hi, sir. Hey, what's up, buddy? What's up? So, in this lecture, we're gonna be basically talking about this distance, what this distance exactly is. If you wanna learn physics, if you wanna take the feel of the concepts from physics, I suggest you to ask this question to yourself. Why are you studying that particular subject? Why are you studying that particular concept? What is the use of that concept in real life? What are the real life applications of that concept? Where does this concept come from? If you get the answer of all these questions, that means you got the feel of that question. That means you got the feel of that concept particularly. Then only you would be able to solve the different level, next level problems from that portion. Understand? This is how we actually understand physics. This is the common rule and this is the golden rule that I want you people to follow. Everybody is liking this one. I love physics now only because of Yawar sir. Okay, thank you. Means a lot. Okay. Sir, very excited. Okay, that's very nice. I can see a lot of people sending the lots and lots of chats. Thank you so much. Okay. So boys and girls, today we're gonna be taking the feel of this distance. What actually this distance is. What actually this displacement is. Is it some sort of distance only or something else? We're gonna be talking about the speed. What is the real life feel of speed? Understand? We're gonna be talking about the velocity. Every speed, instantaneous speed, average velocity, instantaneous velocity. But before understanding all of this stuff, I want you people to listen to a beautiful story. Understand? because we are starting the kinematics. Before that, you should know what exactly this kinematics is. Where does this kinematics exactly come from? Yeah, sir, Yawar sir, best thank you means a lot. Okay, okay. Sir, start teaching. Yes, I already started, man. Sir, you are nice. Everybody. Okay, sir, where can we clear doubts in numericals? There will be no doubt. Okay, if we study, if you learn from this Fury series, if you learn from us, there will definitely no doubt. But still, if you have, you can definitely ask us on Unacademy. You can follow us over there. Message us, we'll clear all the doubts. Okay, we'll try to clear all the doubts. Okay, because a lot of people are messaging us every single day. That's why. So we'll give our 100% to you people. You have to give from your side as well. Okay, okay. So ladies and gentlemen, let me just tell you a beautiful story. What is that beautiful story? I want you people to listen to me very carefully. Okay, let's not waste our time. Let me just tell you that beautiful story. For example, I am sitting over here. Okay, this is the story. I'm taking you back to your previous times, like 200 years before, 300 years before, when there was no physics, when there was no Newton, when there was nothing at all. Okay, so I'm sitting over here. For example, this is me, Yawar A, and there is the other guy. For example, it's you, somebody over here. I'll take the name Anirudh. Okay, and there is the other guy. This is B, this is C, and this is C. We all are basically physicists. For an instance, you assume that we all are basically physicists. Now, what we people are supposed to do over here, we are having the conversation with each other. We are analyzing. See, I am saying right now, right here, everybody, listen to me very carefully. Listen to me very carefully. Okay. See, if you have any sort of doubt, if you feel that you got the doubt, whatever I am teaching, so tell me in the live chat at that time itself, I'll clear it. Understand? Okay. Now listen to me. We are basically sitting over here. There are different number of people. It's me and you people. Understand? So we started analyzing things. This car is in the motion. Understand? This is moving forward. This is the ball. Understand? Which is rolling on the ground. After some time, it stops. And this is the pen, or this is some package. I'm releasing this package from some height. Now, I'm asking you the simple question. I'm a physicist. Understand? For instance, you assume that I'm a physicist. I'm asking you the simple question. If I'm releasing this package, why is it going down? And if this car is moving in the forward direction, after some time it stops. Why does it stop? Understand? Why is its velocity changing? So these are the questions that are hitting my mind. This person is asking the question, if this ball is rolling on this ground, after some time it stops. Why? Huh? You will say because of friction. I'm saying we are 300 years back. There was no friction that time. Understand? But friction hasn't been invented or discovered yet. That is the main word for this. Understand? Okay, so at that point of time, how will you answer all of these questions? The questions related to motion. Why this body is in motion? Why is this stopping after some time? Why is its velocity changing? How much is its velocity? These are basically the questions that we are asking each other. We are analyzing this situation. Understand? These are the questions related to the motion. I'm saying that if this car is moving with a 60 meters per second right now, after 1 hour, where it will be exactly? What will be its position? What will be its new position? These are the questions that are hitting our mind right now. Stop looking at the live chat. Listen to me very carefully. If you get any sort of doubt, then only look at the live chat and type me, sir, we got the doubt, please repeat. Okay, I'll do it at the same time over there only. Okay. So people, so these are the questions which were basically hitting our mind, which were messing with our mind. So what to do? How to answer all of these questions? Questions related to motion. If this is moving after some time, why is it stopping? What is the velocity of this one? How much distance it has covered? Now, physicists, what they did, they introduced the physics branch, a branch of physics. That's what we call the mechanics. They wrote different number of books. In those books, they mentioned the answer of all these questions. What is this velocity? How far it is gonna go? If I'm releasing this package, why is it going down? So in this mechanics, what we basically study, the study of motion. That's why we say this is the oldest branch of physics, 200, 300 years before. So we say this mechanics deals with the study of motion. Everybody is liking this one. Everybody got the feel of this one. Why? What do we exactly study in this mechanics? This is the oldest branch. Here we study the study of motion. Fine. Now, you have in front of you the different number of particles. For example, I'm a physicist. I see in front of me there are different number of particles. There are atoms, there are
molecules, electrons, protons, which are also in motion. So we have to study its motion only. So the motion of these particles comes under the quantum mechanics, which the particles which are having very small size, which are having very less size, like 10 raised power less than 10 raised power minus 6. And we can see this pen is moving, this car is moving, I am moving. In that case, sir, increase the pen width. How to do it? I don't know exactly, man. कैसे करते? Okay, I'll just try to write. Okay. From next class onwards, I can do it. Okay. Right now it's impossible because it's gonna waste our time. Okay. I'll write bit bigger. Okay. You'll get it. You will definitely get it. Now listen to me very carefully. Okay. Now listen to me very carefully. So if I have a finite size of particle in front of me, which is moving with a finite speed, the motion, if we study the motion of that particle, what is its velocity, how far it's gonna go, it comes under the classical mechanics. Here, if the particles are having, if the body is having the finite size, understand? So this is having the different laws. This quantum mechanics is having the different laws. We are not supposed to apply the laws of quantum mechanics on classical mechanics. Neither we are supposed to apply the laws of classical mechanics on the quantum mechanics. See, what is mechanics? Mechanics is nothing but study of motion. Now, study of motion of what? Different number of particles. If we have very small particles like electrons, protons, atoms, molecules, that comes under the quantum mechanics. Motion of those particles come under the quantum mechanics. And the motion of finite size particles comes under the classical mechanics. In our 11th class syllabus, we are dealing with the classical mechanics only. Understand this? Kinematics, dynamics, all comes under the, sir, go a bit slow. Okay, fine. Everybody is understanding this one. Drop a thumbs up. If not, do let me know in the live chat right now. Drop a thumbs up so that I'll get to know everybody is understanding. Come on, man. I want you people to let me know as soon as possible. Come on. Give me some indication, man. Do let me know in the live chat. So many people are watching this lecture. Do let me know if you're understanding this one properly. Drop a thumbs up. If not, drop a thumbs down. Okay? If not, drop a thumbs down. Fine. So, those come under the, sir, change into thick color. Okay, one second, man. Okay, one second, man. I'll just call this. Sir, main difference between kinematics and mechanics. I'll tell you every damn thing. Where does this kinematics lie exactly? I'll tell you. Hello, sir. Yeah, sir, I'm in middle of the class right now. Yeah, one second. I'm calling this love, sir. He'll ask me how to basically increase this thickness. Okay. Understanding, sir. Main difference between kinematics and mechanics. I'll tell you what is mechanics. What is, I already told you. I'll tell you what. Hello? Yeah, sir, I'm in the middle of class right now. Can you please tell me how to increase the thickness of this pen? Where is that exactly? Okay. Thank you, sir. Thank you. Guys. I'll do it from the next class onwards. I have to basically contact the technical team for this. So, okay, sir, little bit slow. Okay, fine. I'll go a little bit slow. And there are the particles which, if this particle is basically moving with the speed of light. So, the motion, if we want to study the motion of this particle, then it comes under the relativistic mechanics. Understand? It comes under the relativistic mechanics. Understand? So the particles which are having the finite size, like I'm moving, this bottle is moving, the car is moving, we say what is the velocity, what is the speed. We are studying the motion of that body which are having the finite size. That comes under the classical mechanics. Okay? And quantum mechanics, in quantum mechanics, we deal with the particles which are very smaller in size, like electrons, protons, like atoms, molecules, so that comes over here. And the particles or the body which is moving with the speed of light, that comes under the relativistic mechanics. Now further, if we talk about the classical mechanics, in our 11th class syllabus, we are supposed to basically focus on, we are supposed to deal with the classical mechanics only. Now see, that's why in your kinematics or in your dynamics, laws of motion, you will basically see the car is moving, we are applying the force on the car, the velocity of the car, or this person is moving, this monkey is basically falling down. So you'll basically, yes, third button on your left. Yeah, I already did. Nothing happened, bro. Okay, I'll do it from the next class onwards. Okay. Now see, if I ask you the simple question, listen to me very carefully. Listen to me very carefully. If I ask you the very simple question, I'll send you the notes as well. Don't ask me these questions right now. If you have any sort of doubt, then ask me. Understand? Then ask me in the live chat. You are asking me to send me the notes. I'll send you the notes. Okay? No any other question. Okay? What is relativistic mechanics once again? Relativistic mechanics deals with the bodies which are in motion, having the speed which are moving with the speed of light. In that case, we cannot apply the laws of quantum mechanics. We cannot apply the laws of classical mechanics. We are supposed to apply the laws of relativistic mechanics only. This is not in our syllabus. We are supposed to deal with the classical mechanics only. So I'm basically making you understand what is the history. Why do we exactly study this kinematics? Where does it exactly come from? That is the main goal of our topic. I hope you got it now. Okay. Fine. A lot of people are sending me chats right now. Not able to read all the chats. Sorry for that. Now listen to me very carefully. If I say, for example, this car over here, this is moving in the forward direction. Fine. So what will basically happen? If this car is moving in the forward direction, or if this car is moving somewhere over there, so we say it is covering some distance. So some displacement it will cover. It will have some speed. It will have some acceleration. So we say it will cover some displacement. It will cover some distance. It will cover or distance, displacement. It will have some velocity. It will have some speed. It will have some acceleration. So these are the parameters which we deal with in kinematics. Understand? When we talk about these parameters, distance, displacement, speed, so that means we are studying the kinematics of that body, where we don't talk about the forces and all. Understand? In kinematics, we see what are all the changes that are happening to the body. What are the changes happening to the body? Its velocities, its speed is changing. It is covering the displacement. It's covering the distance. So when we talk about these parameters only, that means we are studying the kinematics of the body. In kinematics, you will only see displacement, distance, acceleration, velocity. You will see nowhere there is force, torque and all. That comes under the dynamics. Now, if I ask you the simple question, if this car is moving in the forward direction, after some time it stops over here, maybe because of some friction, because of the air friction or some other. So that is basically the force, or you applied some external force over here. So when we talk about these forces, when we deal with these forces, when we deal with this cause, what is basically stopping this body, that means we are talking about the dynamics. So first comes the kinematics. Oh, I'll just rub it over here. First comes this all comes under the classical mechanics. Understand? This all comes under the classical mechanics. First comes the kinematics. Then we have the dynamics. That's why we say Newton's laws of motion is nothing but dynamics. In dynamics, we deal with the forces. If this car is moving, after some time it stops. Why does it stop? If I'm releasing this one, Earth is attracting. I'm saying kheenching in Hindi word, okay? So Earth is attracting this body towards itself. So it's because of the gravity, understand? The center of the Earth is attracting this body towards itself. So that is a force. So when we talk about this stuff, it comes under the dynamics, understand? So whenever we talk about the forces, it comes under the dynamics. Whenever we talk about what are the changes happening to the body, that comes under the kinematics. Everybody understood this one? What is the difference between kinematics and dynamics? Drop a thumbs up right now, right here. Okay, drop a thumbs up, everybody. If you got any sort of confusion, do let me know right now, abhi ke abhi. Right now, do let me know. Sir, the way you teach physics, every bit goes in the mind. Love you, sir. Was looking for a teacher like you for the first time in my... I'm loving physics. Thank you. Means a lot. Thank you. Okay, but I want you people to tell me if you got the feel of this one. Okay, somebody was asking what is this kinematics. Now you got the feel of kinematics, what this kinematics exactly is. Okay. Once more, sir. Once more. All clear. Everybody. All of you send me the thumbs up, because a lot of people are watching this one. Yes, cause of motion dynamics. That's what I said. Cause of motion. What is cause of motion? That is force. Force is basically changing the velocity of the body. Because of the force, the body is stopping. Understand? Okay. Tell me again once more. Okay, some people are saying once more. See, if I say, for example, I'll just write it over here. I'll just make it over here. See, if I say, for example, this is a car. Okay. Look at me. This is moving in the forward direction. For example, this is moving in the forward direction. I say it will cover some distance. It will cover some displacement. Okay, these are the changes that will happen to this body. It will increase its speed. When we talk about the speed, it will have some speed. It will have some velocity, acceleration. Whenever we talk about these parameters, whenever we analyze these parameters, how much is its displacement, how much displacement has covered, what is its velocity, what is its acceleration, that means at that point of time we are talking about the kinematics of its body. We are dealing with the kinematics of the body. Now if I ask you, the velocity of the body is changing, speed of the body is changing, you will say why? It may be because of the force. It may be because of that cause. That cause is because force. Whenever we deal with these forces and all, that means we are talking about the dynamics of the body. Understand? I hope you got the feel now. Arey, friction, external force, internal force, we'll talk about later, bro. Forget that. Right now, we are talking about what is the cause and what is that one. What are the parameters? What is basically happening over here and what is the cause? That is, I'm basically making you understand what is the difference between kinematics and dynamics. What is friction actually? That we'll talk about later. Okay, that we'll talk about later. Okay, I'll change this. I'll make it yellow one. Okay, fine. Now let's move further. Now, what this kinematics in this kind? Now you got the feel of kinematics. I hope yes, you got the feel of this kinematics. Okay. Changes during motion, kinematics, cause of motion, dynamics. Definitely yes. Okay. What? Yes. What are the changes happening to the body, like acceleration, velocity? It comes under the. That means we are studying this one. Come on. Let's have a look on this one. So, in this kinematics, we will be talking about what is this rest and what is this motion. Okay? The simple two terms that we'll be talking about today. Understand? Everybody listen to me very, very carefully. Sir, use the pen. Arey, no. I'll write bit bigger. Don't worry about that. You will get to understand everything. Okay? Okay. Now listen to me. See. I'll make you understand this. If I say, for example, this body over here in simple language, this is not moving. This is not changing its position. I'm sitting over here. Okay. I'm standing over here. That means I'm at rest. Okay. If this body is changing its position, I'm saying this is in motion. I'm in motion right now. I'm moving. I'm having some velocity. Okay, fine. Now, I have a question in my mind that I wanted to actually ask you. Okay. For example, I'm sitting inside this car. There is person A. Okay. So for example, this is the person A inside. And there is this another person. Its name is B. Okay. And this car is moving in the forward direction. This car is in the motion. Now there is this person C, which is exactly at the ground. We say this person is at a rest. For instance, you assume that this person is at the rest. Understand? Okay. So for example, we say this is at the rest, this is at the ground exactly. Now I ask this person B, could you please tell me this A person is in motion right now or this A person is at rest right now? This B person is saying me, I can definitely talk to this A person. I can share whatever I want with this A person. So he is sitting behind me or in my side. So I can definitely say this A is at a rest. According to this B. According to this B, A is at rest. But I am saying this C. Could you please tell me this A is at rest or this A is in motion. This C is saying me that this car is moving with the velocity V in the forward direction. So he's saying this A is also moving with the velocity, with same velocity. This A is also in the motion. So according to this person C, this person A is in motion. Now, could you please tell me who is correct? Who is correct? Yes, yes, we need a frame of reference over here. That is what I'm gonna basically make you understand. Yes, definitely. Now see, both are actually correct. It depends with what frame of reference you are talking about, with what person you are talking about. Understand? If we take this as frame of reference, understand? Frame of reference can be anything. Understand? According to what? Frame of reference means observer, who is observing this situation. Right now, if I say this is the frame of reference, means this person is the observer. This person C is observing this situation. So according to this observer, according to this frame of reference, this car is in motion. So A is in motion. He is absolutely correct. Understand? So initially the question was incomplete. I would have said, asked you that according to this person, see, what is this in motion or is this at motion? Is this in motion or is this at rest? That is the complete question. So we have to basically say according to the frame of reference. We have to use the frame of reference every single time. Understand? Everybody, yes, both are correct. Both are absolutely correct. According to this person B, this A is in motion. Understand? When we take this as frame of reference, when we take this B as frame of reference, then this A is definitely at rest. It depends. It completely depends upon us who we are going to take as observer, who we are going to take as the frame of reference. Everybody understood the concept of frame of reference? Everybody understood the frame of reference? Do let me know in the live chat. Yes or no. That's we say rest and motion are relative. Understand? Okay. Everybody. Drop a thumbs up. Drop a thumbs up. Understand? We say rest and motion are relative. It depends with what frame of reference we are talking about. It completely depends with what frame of reference, with what observer we are talking about. Then we can only say that that person or that body is at rest or that body is in motion. Understand? We have to mention the frame of reference. That is mandatory. That is mandatory. Everybody, if you got the feel of this one, drop a thumbs up and do write crystal clear. I want this word. I like this word. Crystal clear. Yes. Are yaar, somebody is saying once again. It was so easy. It was so damn easy, man. Annamalai. What happened, bro? What happened, bro? What happened, bro? It's gonna take a lot of time if I keep basically. Sir, then according to B, rest. Then according to A, is B at rest? According to A, is B at rest? Definitely yes. So one and the same thing. If you are taking this as observer and observing this one, this B, he's at rest. Or if you are taking this as observer and observing this A, he is also at rest. One and the same thing, bro. Sir, I can surely say I have not seen any physics teacher teaching in English like you. You are awesome. In India, like you are awesome. Thank you. Yes, definitely. Yes, yes, yes. Crystal clear. Everybody. Okay, okay. Let's move. Let's move. Let's move forward. Yes. Arey, Harsha, you got the feel. Yes, completely. Yes, you are right. According to this is at rest. According to this, A is also at rest. Yes, definitely. Love you, sir. Love you too. Means a lot. Okay, okay. A definition of frame of reference. Hey, you find that definition in your book, bro. Okay. According to what you are talking about, frame of reference is nothing but observer. We are teaching, I'm teaching you JEE right over here, okay? I'm not saying you the definitions. I'm not supposed to say you the definitions. You can find the definition everywhere. Come on, let's move. Now, we have this translational motion. Understand what is this translational motion? We'll deal with the different types of motions. Then, okay, I'm from Karnataka. That's very nice. Okay, love you, sir. Love you too. Okay. Okay. Now see, everybody listen to me very carefully. We will be talking about the rectilinear motion now. We'll be talking about the curvilinear motion now. Before that, we'll be talking about this translation motion. If the body is in motion, listen to me very carefully. Don't look at the chat right now. Listen to me. Okay. If this body is in motion right now, if this body is moving in the forward direction, okay, I say, if the road is straight, I can definitely say this is the translation motion. In simple words, I'm saying you just take a stamp and put it on your heart. Okay? Okay, everybody, listen to me very carefully. Fine. Now see, this translation motion, if this body is moving in the forward direction on a straight road, understand, we say this is translation motion. Now the second point is, if the same body is moving like this in a curved path, I can say this is also the translation motion. Now it depends. This motion in which the path is straight, we call this as rectilinear translation motion. This motion in which the path is curved, this is what we call the curvilinear translation motion. I will make you understand both very properly, and I'll give you the definition of this translation motion according to the physics as well. Now let me just make you understand this translation motion according to the physics. Understand? Let's have a look. Everybody listen to me very carefully. How many lectures on kinematics? We'll see, bro. I'll teach you every damn thing. We'll see. Okay, listen to me very carefully. Now, have a look on this one. I want you people to look at me right now. Don't look at your chat box. Come on. Okay. Forget about the chat box right now. Look at me. If you got any sort of confusion, then only ask me. Okay? Fine. Now see. What is the definition of this translation motion according to the physics? Okay, what is the definition of this translation motion according to the physics? See, if I say, for example, this is the body over here. If I say, for example, this is the body over here. Arey yaar, isko karta hoon. I'll just rub it. See, if I say this is the body over here, understand, and this is moving in the forward direction. For example, this is moving in the forward direction like this. This is moving like this on a straight road, understand? If I take two internal points, and if I join the line between these two internal points, this straight line, and finally the body will reach over here because this is moving in the forward direction, and I will see the same line will reach over here finally, and I will see the same line will reach finally over here. And if the line joining the 2 points remains parallel to itself throughout the motion, we say this is called the translational motion. This is the condition for translation motion. If I take these two internal points, for example, this is a body, this is moving in the forward direction. Take two internal points. This is the point number 1. This is the point number 2. And if this line, assume that there is a line between these 2 points. If this line remains parallel to itself, then we say this is the translation motion. It is not changing its orientation. If this is not parallel to itself, then it will look like this. It will look initially like this, finally like this. Understand? But it remains parallel to itself throughout the motion. Then we say this is the translation motion. Everybody understood this one? Drop a thumbs up. Right now, right here. Jaldi say. I want everybody of you to send me the thumbs up if you got this one. Okay. The marker intensity is dim. Arey yaar. I'll change it from the next class onwards. Now, if I do it, it's gonna take lots and lots of time. It will definitely waste your time as well. Okay? Yeah. Example train. You can take it, okay? Okay. Now, listen to me very carefully. Now, see, I'll just make you more understand this translation motion. Each point on this line, everybody, listen to me very carefully. Each point, I'll just mark it with this. Each point on this line, for example, this point, if I take different number of points, they are moving synchronously. They are moving parallelly to each other. If this is moving in the forward direction, this will also move. This will also move. They are moving parallelly. They will cover the same displacement. if this body is moving in the forward direction, different number of points will cover the same displacement. If this will cover 2 meters, this will also cover 2 meters, this will also cover 2 meters. Understand? All of these. This will move with the same velocity as this particle is moving. All the particles are moving synchronously. That means all the particles move with the same velocity. All the particles will have same acceleration. This is the beauty of translational motion. This is the beauty of this rectilinear translation motion. Now let me tell you, let me just make you understand this curvilinear translation motion. See what this curvilinear translation motion is. What is the first condition for translation motion? That is, the line joining the 2 points should remain parallel to itself. Arey bhai, if you are liking this class, drop a thumbs up. Okay, I'll get more energy then. Sir, please start magnetism in plus for JEE 2022, please. Right now we study this. It's for JEE 2023. Not for, there is no JEE 2023, there is no JEE 2020. This is for everybody, okay? I want everybody of you to join my class. Join Love Sir's class, okay? This Fury Live is for everybody. This Fury Live is for everybody, okay? Now listen to me, don't distract me, please, okay? You are wasting your own time, okay? So that's why I'm saying right now, if you have any sort of doubt, then only ask me in the chat box. Don't keep on saying this, wo, ye, wo, he, okay? And thank you so much for so much love. means a lot, okay? Now look at me. I'll make you understand this curvilinear translation motion. What is translation motion? The line joining between two internal points has to remain parallel to itself. Now see, curvilinear translation motion. If I say, for example, this is the body over here, understand? This is moving like this in a curved path. This is moving like this in a curved path. Let's see if the line joining the 2 points remains parallel to itself or not. This is moving like this. Finally, the body reached over here. Finally, the body reached over here. Understand? Now, let me just take 2 points, 2 internal points. This is the first one. Okay. Let me just take 2 points. This is the first one and this is the second one. Understand? This is the line joining the 2 points. Finally, over here, I'll take the same line joining the 2 points. If I say this is point A, this is point B, same point A, same point B. And over here, this is the point A and this is the point B. Everybody, now tell me, is this line joining the 2 points parallel to itself throughout the motion? 100% yes, bro. Over here, it is like this initially. Over here, it is like this initially, okay? And at the second point, it is like this, understand? And finally, it is like this, but this is parallel to itself, understand? I know this is bit down, but this is parallel to itself. So I can say this is translational motion because that is the condition. The line has to remain parallel to itself. But this is what translation motion? This is curvilinear translation motion because the path is curved over here. The path is curved over here, understand? So if I take this point over here, all the points will basically move synchronously. In translation motion, all the points move synchronously. When this point is moving in the upward direction, this will also move in the upward direction. This will also move in the upward direction parallel to itself. And all of these points will have same velocity. All the points will have same displacement. I'm in 10th, still watching. All the points will have same velocity. All the points will have same acceleration. They are moving synchronously. Everybody understood what is the translational motion, direct linear translation motion, curvilinear translation motion. Drop a thumbs up. Right now, drop a thumbs up. You got the feel of this one? You got the feel of this one? Okay, I'll do color from now onwards. Everybody understood this one? Anybody got any sort of confusion? Come on, man. Come on, man. Come on, man. Yawar sir, OP. Drop a thumbs up if you got this one. If there is any confusion. Rectilinear, parallel and line path, curvilinear but curved path. Yes, definitely. Yes. The main point, the main idea of this one is basically the line has to remain parallel to itself. Understand? And if you talk about the rotational motion, for example, I'll just give you the example over here. If you talk about the rotational motion, if we have a look on the rotational motion, I am exactly fixing this rod over here. This is not even in our syllabus right now. I'm just making you understand. If this rod is rotating about this one, about this point, understand? This hinge. Essay. So initially, the line joining the 2 points is like this. Finally, the line joining the 2 points is like this. Understand? So initially like this, finally like this. Is this parallel to itself? No, it is cutting some angle. That's what we call the rotational motion. So it is not translational motion. I hope you got the feel of this one. I hope you got the feel of this one. Let's move. Let's move. This rectilinear translational motion is also called the one-dimensional motion. Understand? This curvilinear translational motion, in this we have further two types, two-dimensional motion and three-dimensional motion. I'll make you understand both of these. Understand? I'll just make you understand. Now let's move. Let's move. See, one-dimensional motion. What is one-dimensional motion? When only one of the coordinates of a body are changing. Understand? If this body is moving, which coordinate of this body is changing? Yeah, only x coordinate. Now, I am saying, for example, if you make the coordinate axis, y-axis over here like this, okay? Now see, this is moving in the forward direction. At this point, if I say x is equal to 0, one of its coordinates, over here, x will be 1. And when the body will reach over here, x will be 2. And when the body moves further, x will be 3, 4, 5. So which of the coordinates of a body are changing? Only x coordinate, only one of its coordinates. And what is the y? Y coordinate is, I would say initially, y coordinate is over here, that is 0. So y coordinate will remain 0 throughout the motion because this is moving horizontally. This is a horizontal motion. Only one of its coordinates are changing. So I can say this is nothing but one-dimensional motion, in which only one of the dimensions are changing. Only one of the coordinates are changing exactly. That's why we say this is one-dimensional motion. Is this, if I'm releasing this, if I'm releasing this free fall, if I'm releasing this, look at me. If I'm releasing this, it's falling down. Is how many of the coordinates of this body are changing right now? Do let me know in the live chat, okay? Everybody. Okay? Do let me know in the live chat. If I am releasing this ball, if I'm releasing this ball, understand, in the downward direction, it's moving in the downward direction. Is this one-dimensional motion or two-dimensional motion? Everybody, do let me know in the live chat. Come on, send me as soon as possible. I'm waiting for everybody of you. Come on, send me, man. Huh? Do let me know in the live chat. Will you start maths in this channel? We'll start maths in this channel, okay? Yes. Everybody, do let me know in the live chat, all of you. Some people are saying 1D, some people are saying 2D. People are saying 2D, 2D, 1D. Arey yaar, how is it 2D, man? How is it 2D? Only one of its coordinates are changing. That is one-dimensional motion. If I'm releasing this, when the ball reaches over here, for example, at this point, its y is, for example, if I say 4 meters. When the ball reaches over here, its y will be 3. And when the ball reaches over here, its y will be 0. But x is same, x is same. When the ball is exactly over here, x is, for example, 2, 0, 1, 3. That will be same na, for throughout the motion. So its y coordinate is changing. Here x coordinate is changing. When one of the coordinates of a body are changing, we say one-dimensional motion. Here also one is changing. That is why here x is changing. So this is 1D. Everybody got this one. Everybody got this one. Hey, come on, I want everybody of you to like this session right now, right here. And once the session ends, I want to know from you guys, how was the session? Do comment and do share with this your friends, okay? All of you, all of you. Session PDF link, I'll share the PDF as well. Don't worry about that. Okay, I'll share the PDF. Come on, come on. Now let's move. Two-dimensional motion. Simply, when two of the coordinates are changing. If I say I am throwing... No. Please tell me one-dimensional motion again. No. Arey yaar. One-dimensional motion means in which one of the coordinates are changing. For example, if I make this is y-axis, this is x-axis. And this car is moving on a straight road. Khali only x is changing na. So y remains same. Here I am saying y is 0, 1, 2. How much you say? For example, if it is y is 0 initially, so it will remain 0, 0, 0. But its x is changing. Here x is 1, 2, 3, 4, 5. So this is one-dimensional motion. Chalo, let's move on to the two-dimensional motion now. Let's move on to the two-dimensional motion now. Let's move on to the two. We have to do lots and lots of questions by today itself, man. Okay. So I don't want you people to waste my time as well as yours as well. Now, two-dimensional motion. What is two-dimensional motion exactly? In which two of the coordinates are changing. I am throwing this ball from here to here. This is a projectile motion. So now I'm throwing this ball, I'm launching this ball, and it reaches finally. I'm throwing this stone from this point to this point. It will follow this path, this parabolic path. Understand? So in that case, two of the coordinates are changing, because when the ball is exactly at this point, we say this much is its y and this much is its x. This is its x and this is its y. And when the ball reaches this point, now y has increased and x has already also increased. When the ball reaches this point, y changes, x changes. In this, both of the coordinates are changing. Both of the coordinates are changing. We say this is two-dimensional motion. For this, you can take the example as real life example as that billiard ball table. Understand? Oh, pool. I'm not able to pronunciate that exactly. Okay. That is the example of two-dimensional motion, in which two dimensions, in which two of the dimensions of a body are changing when that ball is basically moving. Understand? Okay, everybody got this crystal clear? Do let me know. Right, crystal clear, right, crystal clear. Come on, right, crystal clear. Okay, let's move. Three-dimensional motion, in which three dimensions are changing, all the three dimensions. Example, kite. Okay, kite. When kite is basically moving, all the three dimensions are moving. All the three dimensions are changing. All the three of the coordinates are changing. See, in this case, only two of the coordinates are changing, like in projectile motion. When there is three-dimensional motion, it's moving like this in 3D. All the three dimensions are changing. Understand? Or example of a flight plane. When the plane is in the air, that is the three-dimensional motion. I hope you got the feel of this one. Let's move forward. Now we have this beautiful distance and we have this displacement. Somebody was saying yesterday, sir, will you start from basics? Our basics is very unclear. So curvilinear motion is two-dimensional motion. Absolutely, yes. Yes. That's what I told you previously. Curvilinear motion is basically two-dimensional motion. Understand? And curvilinear motion is also three-dimensional motion. In this air, this is also the curvilinear motion in 3D. Everybody? Okay. Flying bird example. Yes, that is very nice. Good example. Flying bird is an also example of three-dimensional motion. Come on, man. Now, let me tell you what is distance exactly and what is displacement exactly. Let's just have a look on displacement and the distance exactly. Come on, I want everybody of you to tell me what is this distance exactly. Now see, I'll basically make you understand what this distance and displacement exactly is. For example, I am living over here. This is A, and I want to travel from A point to B point. This is A, this is B. I'm living over here. My friend lives over here. Understand? Understood this? Okay. Is there anything like four-dimensional? Okay, let's have a look on this one, okay? I want everybody of you listen to me very carefully and like this session, man. We'll have a conversation later on. Now, if I have to travel from A point to B point, if I have to travel from my home to my friend's home, so there are so many basically ways to go. There are so many roads that government has basically made. This is the first one. This is the second one. This is the third one. This is the fourth one. And this is exactly the fifth one. Okay. Now, first of all, I'm traveling through this road. This is the road number one. Second of all, I'm traveling through this road, and then I travel through this road, then I travel through this road, and then I travel through this path. Understand? These are all the paths through which I can basically travel. When I'm traveling through this path number one, could you please tell me what I am covering exactly? I am covering exactly the distance. I am moving to somewhere. I am changing my position, so I am covering the distance. If I'm sitting over here, if I'm standing over here only, I'm not moving. So I can basically say I'm not changing my distance. My distance is basically, if I'm exactly over here, I'm at rest. So now if I start moving in the forward direction, backward direction, that means I am covering some distance. So when I go from this point to this point through this path, I am covering the distance. When I go from this point to this point through this path, I am covering the distance. When I go from this point to this point through this path, I'm covering the distance. And when I go from this point to this point through this path, I'm covering the distance. I'm covering the distance. Now the point is, listen to me very carefully. I'll make you understand what is the difference between distance and displacement. Now the point is, all of these are distances. Among all of these 5 distances, there is one distance that is a special type of distance. That is a special type of distance. Which one is that? This one is that. This is what we call the special type of distance. This is what we call the special type of distance. Why is this special type of distance? Because first of all, this is the shortest path from A point to B point. Understand? Point number 1, there is no other shortest path than this. Understand? The second point is from A point to B point. This is the only path which is giving you the unique direction, particular direction. That is towards B. It is pointing towards B. It is pointing towards B. Understand? That's why this is the special type of distance. Understand? So all of these are basically distances. When we travel from A point to B point through any path, we are covering the distance. But when we travel through this path, means we are covering the special type of distance. This special type of distance is nothing but it is called the displacement. Understand? Now, what is this distance? This special type of distance, this is what we call the distance. This is what we call the displacement. It is what we call the shortest path. It is what we call the special type of distance, and it is having the particular direction. It is pointing us towards the B. And the other point basically about this one, displacement, it is, first of all, it is a shortest path. Second, it is having unique direction. Third point is depends upon initial and final point. Everybody is understanding this one. Now, what is this? Depends upon the initial point and final point. Longest path and shortest path. Yeah, distance is a scalar quantity. I'll tell you everything, man. Sir, when will you say the differentiation and integration? I'll teach you that as well. I'll teach you that as well, okay? Okay. Okay. All distances, displacements are distance. All distances are not displacement. I'll tell you that also, man. Okay. Till this point, is everything crystalline clear? Do let me know in the live chat. Now see, it depends upon the initial point and final point. What does that mean exactly? Now see, if I have to travel from A point to B point, I'm saying that if I'm covering this displacement, this shortest path, it depends upon the initial point and final point. That means I'm saying you just take the initial point, that is this initial point. Take the final point, this is the final point. Now close your eyes and take this line, this will give you the displacement. That's why I'm saying it depends upon initial point, final point. Initial point, final point, take the line and it will give you the displacement. Understand? So when we talk about the distance, you have to travel through that exact path. Understand? That is the exact path. Now I'll make you just understand over here. If I travel from this point and I have to reach this point, if I go like this is the actual path I have traveled. This is what we call the distance, the actual path traveled. And if I tell you, is there any shortest path through which I can basically reach from this point to this point in very less amount of time, you will say yes. That is what we call the displacement. That is the shortest path giving you the particular direction. This distance is not having the particular direction. It is pointing like this. At this point, it is pointing downwards. Here it is pointing upwards. This is having the different direction at different points. Yeah, it means the starting point. Yes. Initial point means starting point. Final point means final point. Yes. Yes, everybody. Is this crystal clear? Is this crystal clear? Is this crystal clear? Do let me know in the live chat. Do let me know in the live chat if this is crystal clear to everyone. Okay, okay. I want you people to have a look on this one right now, okay? So depends upon initial and final point. Everybody got this one. Everybody got this one. Now, the fourth point, if I talk about this, a displacement can be positive, this displacement can be negative. Understand? This can be positive, this can be negative. We basically measure this displacement in meters, okay? It can be positive, it can be negative. It can be positive slash can be negative. Let me just make you understand this one. What does this mean? What does it actually mean, this positive and negative? Now see, for example, this is the point from where I am measuring. If I travel from this point to this point and I reach at this point exactly. Now see, okay? Now over here, I say, for example, at this point, displacement is basically 0. We represent displacement by S, X, whatever you like, okay? So at this point, displacement is 0 because I am measuring from this point. If I go over here, so I traveled 1 meter, 2 meters, 3 meters, 5 meters over here. So I say displacement is nothing but 5 meters over here. We say plus 5. So where you are exactly sitting over here, that means the displacement we take positive if you are sitting on the right direction of this what we call the origin. So that means we take displacement as positive. If you are sitting over here, somewhere over here from the left side of the origin, we say S is equal to negative. It means your displacement is negative. See, displacement negative and positive doesn't basically tell you the displacement, the direction of motion. See. What I'm trying to basically make you understand is, if I say, for example, this car is moving in the right direction, or if I say, for example, this car is having displacement plus 10 meters, okay? Does it actually mean the car is moving in the right direction? Do let me know in the live chat right now. Okay, do let me know in the live chat right now. Chemistry class is exactly at 8 p.m. Okay, that is at 8 o'clock. So we have 1 hour. Okay, we have 1 hour left. See, I'm asking you the simple question. Okay, if this car is moving, if this car is having basically the plus 10 meters displacement, does it mean the car is moving in the right direction? Yes or no in the live chat? Yes or no in the live chat? Arey, do let me know, yes or no. I want to know the answer of this question. Come on, everybody of you. Arey, khushi yaar. No, I have made you understand this previously also. No. If the car is moving in the right direction, that means its velocity is positive. If the velocity is positive, we say body is moving in the right direction. If velocity is negative, we say the body is moving in the left direction. This displacement positive or negative only tells us where the body exactly is from the origin. At 5 meters in the right direction, at negative 5 meters in the left direction. That is the only point that you people need to understand. Okay. Okay. Somebody is saying sunnat tarike se pani piyo, sir. Thank you. I like it. Definitely yes. I'll follow this. Okay, come on, everybody. I want everybody of you. Okay, you got this one. You got this one. I hope yes. Come on. So now we'll try to solve a few of the questions. I want you people to tell me over here what is basically the distance traveled and what is the displacement. A car is traveling from A point to B point. It has traveled 30 kilometers along this path, and along this path is basically 50 kilometers long. Could you please tell me what is the displacement and what is the distance over here? Okay, somebody is basically saying, what is this distance? Distance is basically the actual path traveled. If you travel from this point to this point through this path, okay, through this path, understand? So this is the actual path through which you are actually traveling, understand? So in that case, in this case, we say this is nothing but distance, actual path traveled. This is the longest path, actual path traveled. And if I ask you, is there any shortest path between these two? You will say, yes, that is this one. So we call this as displacement, understand? This is also the distance, but this is a special type of distance. So that is what we call the displacement, understand? And if you travel through this path only, then displacement is this only and the distance is the same only. Understand? That displacement and distance and displacement both are same. Okay, tell me what is the answer of this question, everybody. Come on, I want everybody of you to basically tell me what is the answer of this question. Okay, सबसे पहले, if we are traveling from this point to this point, which of the two paths are having the particular direction and which one is the shortest path? Obviously, this is the shortest path. From this point to this point, this is the shortest path. So I can say this is simply the displacement. So displacement is nothing but 30 kilometers. Okay, and what is this? This is what we call the displacement, distance. If you travel through like this, this is the actual path, that is 50 kilometers. Okay, in this case. Chalo, I want you people to tell me what is the distance over here and what is the displacement over here. Come on, this is a very simple question. Can I basically say distance is nothing but, in this case, that is the actual path traveled. If the car travels through like this, and reaches this point B, from A point to B point. So what is the actual path traveled? That is 3 kilometers plus 4 kilometers, that is 7 kilometers, simply. And what is the shortest path between A point and B point? That is this one, Can I call this as displacement? Definitely. And how to find this displacement? That is nothing but root of 3 square plus 4 square. Can we find it like this? Definitely. It will be nothing but 5, because this is 9, this is 16, that's 25, root 25, that is 5. So displacement will be nothing but, that is 5. See, if you want to basically understand what displacement exactly is, displacement is basically how much you have displaced from your initial position. So from your initial position, you are displaced only this much. Understand? So, and distance is basically how much you have traveled actually. So this much you have actually traveled. And displacement is how much you have displaced. That is this much only. Everybody is liking this one. Come on, I want everybody of you to tell me. Okay, in this case, could you please tell me what is distance and what is displacement? Could you please tell me what is distance and displacement? Eid Mubarak. Eid is gone, bro. Eid is gone. Come on. In this case, you are traveling from A point to B point through this path only. In this case, displacement is 30. In this case, distance is 30. Actual path traveled is 30, and the shortest path also is basically 30. Understand? Distance and displacement are basically same. Now, this question. You started your car in the morning and you traveled from 5,000 kilometers, and basically you are reading. Initially, your reading of the car was 5,000 kilometers, and finally, when you reached back home, the reading of the car is 6,200 kilometers. Now, could you please tell me, and you parked the car at the same place in the same garage, okay? Could you please tell me, in this case, how much is the displacement and how much is the distance? Come on, I want everybody of you to answer me. The reading, the speedometer of the car is basically showing, or that reading, which is which mentions over there that how much your car has basically traveled till now. So it is showing 5,000 kilometers in the morning, and when you reached back home after traveling so much of distance, when you reached back home, it is showing 6,200 kilometers. I want you people to tell me what is the displacement and what is the distance. Come on. Both are same. Arey yaar, how can distance and displacement be same in both the cases? In this case, come on, everybody. Yes, people are saying 1200 is distance. That's very nice. And what about displacement? Yes, people are saying displacement is 0. Exactly. What is displacement? Displacement tells you how much you have displaced from your initial point. Displacement can be 0 also. Displacement can be positive also. Displacement can be negative also. Distance cannot be 0, bro. Come on. Distance can be positive only. Now see, look at this point. You initially, the car was basically parked over here in your garage. So you traveled for the entire day and you parked back in the same garage. So how much you have displaced? Initial point is this only, final point is this only. When the initial point and final point are same, that means the displacement is 0 because the car hasn't displaced actually. So we say displacement is 0. And what is the distance? Distance is how much you have traveled throughout the entire day. So can I say basically that is nothing but how much is the final reading, that is 6200, minus what is the initial reading, that is 5000. So it will be nothing but 1200 kilometers. So this is nothing but displacement. This is nothing but distance, that is 1200 kilometers. Everybody is understanding this one. These are the basic problems. Everybody can solve this one. Come on, man. How are you? You are preparing for your JEE exam. You are preparing for your JEE exam even. And you are answering wrong. How are you supposed to basically do it like this? Come on, man. And I want everybody of you to basically like this session as soon as possible. Come on, everybody. Crystal clear, that's very nice. Chalo. In this case, could you please tell me what is the distance and displacement? See, you traveled from this point A and you reached this point B. And after that, you traveled from this point B and you reached A again. Finally, could you please tell me how much is the distance and how much is the displacement? Can I say in this case, distance is nothing but actual path traveled, how much you have covered the distance throughout this journey? That is 4 plus 3 plus 2. How much? That is 9. And you reached A again. That is 9 plus 9. Because this 2 plus 3 plus 4 again, that is 9. So 9 plus 9, that is 18 kilometers, meters, whatever is given over there. And what is the displacement? That is 0. Because you reached A again, that means initial and final point are same. You have not displaced from your initial point. So I can basically say displacement is 0. Distance cannot be 9. Distance is 18. Distance is 18. Everybody. Mohan Krishna, distance is 18, not 9. Because you reached A again. You traveled from A to B and from B to A once again. Displacement is 0. Distance is 18. Everybody is liking this one. Everybody is liking this one. Do let me know in the live chat. Okay. Let's move. Let's talk about the speed. Let's talk about the speed. I have got so many problems in this section only, okay? And I want everybody of you to basically stay with me, stick with me till the end of the session, because there are like 9 to 10 problems coming up which are very nice, okay? You will love all of those. Clear, Sergi, that's very nice. Okay. Okay, crystal clear. Okay, let's move. Let's talk about the speed now. What is the speed? Could you please tell me what is the speed? Can anybody of you tell me what is the speed? What actually the speed is? Attendance marked, sir. I want everybody of you to mark the attendance. And how can you do that? You have to basically like the session. Okay, that's the way how we JEE English Unacademy people mark the attendance. We will be till end, sir. Okay, Praveen, you liking this one? Lakshmi saying clear, sir. That's very nice. Distance by time. I'll give you the actual feel of speed. What actually the speed is. Do you guys know what is this rate of change? A rate of change. Rate of change is a golden concept. This is a pure gold. Everything, whatever you see around you is a rate of change. Understand? I'll make you understand this rate of change. Force is rate of change. Acceleration is rate of change. Velocity is rate of change. Snap is rate of change. Enjoying class, sir. Okay, that's nice. Rate of change of distance. Okay, that's very nice. Come on, let's have a look. Let's understand the speed, exactly what the speed is all about. Now see, ladies and gentlemen, boys and girls, I want you people to listen to me very carefully. Now, we're going to be talking about the speed. What the speed actually is. If I say I'm traveling from this A point to B point like this, okay? Now, when I finally reached B, I asked you the simple question. How fast you were traveling, understand? Or how fast you were changing the distance. You will simply say that is change in distance. change in distance. And in how much amount of time, you will say change in time. Understand? When you traveled from A to B and when you finally reached B, I'm asking you the simple question, how much is your change in distance and how much is your change in time? You will say this much, you will say this much. Understand? It's the simple question. Can we write this finally? It is change in distance. How do we write the change in distance mathematically? Delta D from A to B in general upon delta T. This is change in distance upon change in time. 100% we can say it like this. Now, if I say you from A to B, you have traveled 500 kilometers, understand? Or you have traveled 100 kilometers simply. And in how much amount of time? That is 5 hours time. Now, could you please tell me how much is the change in distance from A to B? If we don't know speed yet, we haven't introduced the concept of speed yet. I'm just giving you the feel. I'm trying to give you the feel from the basics, okay? Now, how much is the change in distance? You will say change in distance is from this point to this point. From this point to this point. So this much is the change in distance. Yeah, what is change in distance? If I'm exactly right now over here, if I move forward, that means this much is the change in distance. Understand? If I move further, this much is the change in distance. Understand? So from A point to B point, this much is the change in distance, or this much is the distance covered, total distance covered, one and the same thing. So can I say, how can we find that? That is, when you reached here, you have covered 100 kilometers. Initially here, it was 0 kilometers. So change in distance is how much? Final point minus initial point. Final point minus initial point. Can I say this is 100 minus 0 upon this is 5 minus 0? It is coming out to be 20 kilometer per hour. Because we measure the distance in kilometers and this in hours. Fine. Time in hours, for example, over here, because I said 5 hours. Now, what is this 20 kilometer per hour? This 20 kilometer per hour is basically giving us the information how fast the distance is changing with time. That means every hour I'm covering the 20 kilometers. Every hour I am covering the 20 kilometers. Instead of 20 kilometers, if I write over here, this is 100 kilometers per hour. It means that every hour I'm covering the 100 kilometers. If I say you, it is 200 kilometers per hour. So it means that every hour I'm covering the 200 kilometers. So change in distance is very fast. Change in distance is happening very fastly. Understand? 200 kilometers every hour, 100 kilometers every hour, only 20 kilometers every hour. So that means, what is this? This is nothing but rate of change of distance with time. How fast distance is changing with time. If I am changing distance very fastly with time, that means I'm going very fastly. Understand? My speed is actually more. Understand? Now, this rate of change of distance, this 20 kilometer per hour, how fast distance is changing with time. What is the rate of change of distance with time? Ultimately, we gave it a best name, the beautiful name. That is what we call the speed. Now, what is speed? This is the actual feel of speed. Everybody will tell you a change in distance. What is the actual feel of change in distance? How fast you are changing the distance. More fastly you are changing the distance, your speed is more. Less fastly you are changing the distance, your speed is low. Understand? Everybody got this one? Sir, you do answer for the last sum, please. Which one? Which one you're talking about? Which one? I don't know which one you are talking about. This one or this one? Do let me know. If there is any calculation mistake, you can do it by yourself. You just have to basically understand the concept. It was correct. The question should, reading of the car, it's 200, 1200. Everything is correct, I guess. Hey, I want you people to tell me right now, right here, you got the feel of speed, what actually the speed is. What actually the speed is. Do let me know in the live chat right now. You got the feel of speed, the rate of change of distance. Now you got the feel of what is rate of change. Rate of change can be anything. We say this delta y by delta x. This is what we basically study in differentiation. Delta y by delta x. Y is changing with x. How fast y is changing with x? Understand? If we change x, how fastly y is changing. Same is the case what delta d by delta t. How fast distance is changing with time. That rate of change of distance, we give it a name as speed. Oh. Come on, everybody. Displacement 2400. No. Everybody do let me know in the live chat. I got the feel. That's very nice. I want you people to write me in the live chat right now that crystal clear, crystal clear, crystal clear. Come on, everybody. Then I'll have to repeat it and it will make me feel bad. Sir, who is going to teach the maths in this channel? You will get to know very soon, bro. Let's not talk about that right now, because we're completely in physics right now, understanding physics, getting the feel of physics. Everybody got the feel of what actually the speed is. Everybody will say you speed is nothing but how fast we are going. Now, what actually speed is from the mathematical point of view, from the differentiation point of view, what actually speed is, that is this one. Rate of change of distance, how fast distance is changing. I hope you got the feel of distance as well. Okay, I guarantee you nobody can explain you like this. I guarantee you. Watch all the lectures on the speed, velocity, and tell me if anyone else can basically make you understand like this. Fine. Please increase speed. Yes, I'll do, because is my chat visible? Yes, everybody's chat is visible. Okay, now ladies and gentlemen, boys and girls. So what is the speed? So can we say this speed is nothing but change in distance delta d upon delta t? 100% I can say it like this. Now you tell me one thing. You told me from A point to B point in general speed. Did I ask you to tell me the speed from when you basically were leaving this point A? Or did I ask you to tell me the speed when you were exactly at point B or at any other point? No. So you asked me the speed. You told me the speed. We found the speed from A point to B. That is in general. So can I say this is nothing but average speed that we got from A point to B point? This 20 km/h is the average speed. Average from A point to B point. How much is the average rate of change? This is nothing but average rate of change, average rate of change. I hope you got the feel of this one, average rate of change. That's why we call this as delta d by delta t. That's why we call this delta y by delta x as average rate of change. In general, how fast was displacement or distance changing from A point to B in general? Understand, that is average rate of change. Now, ladies and gentlemen, what if I ask you to tell me the speed at any particular point at this point? At t is equal to 15 seconds. What if I ask you to tell me the speed when you were exactly at this point? How you are supposed to find that? By using the concept of differentiation, because the differentiation helps us to find the rate of change at any particular point. Because what is speed? Speed is nothing but rate of change. Okay, we do have chemistry class. Yes, you have chemistry class. That's at 8 p.m. 8 o'clock. We have to basically finish till 8 o'clock. We have to definitely finish till 8 o'clock. So from A point to B point. अरे यार क्या हो गया इसको? Yes, we got this back. ठीक है? From A point to B point we got the speed. But if I tell you to tell me the speed at any particular point, how do we find that exactly? By using the concept of differentiation. Now if I keep explaining how exactly, what is the real feel behind that, what is the logic behind that, that's gonna take lots and lots of time, because that will take us to the differentiation. Okay, differentiation lecture. So I'm not gonna basically waste the time on that one. So at this point of time, if we are supposed to find the speed, that is nothing but speed at any instant. That is what we call the speed instantaneous speed. So that is nothing but, how do we, every speed was delta d by delta t. Instantaneous speed means, what is delta t? That is change in displacement from A to B in general. Large change by large change. What is instantaneous change? That is very small change. So it will be nothing but dd by dt. Small change by small change. It means that at this particular point, how fast distance is changing at this particular point with time. I hope you got the feel of this one. Understand? There is a beautiful logic behind this. How do we actually find the speed from this point to this point? And how do we actually find the speed at any particular point? That is given by the concept of differentiation. Let me just tell you in 2 seconds. Have a look over here. Okay. Now see, from A point to B point, we got the speed from A point to B point. That's delta d by delta t. Okay. We found that by using that formula, speed is equal to distance upon time. Okay, fine. Now at this particular point of time, what we exactly did, we decreased this time interval. We made this time interval very small. When we made this time interval very small, it became dt from delta d, and this is approximately equal to 0, but not equal to 0 exactly. Understand? It is approximately equal to 0. And in this small time interval, small change in time, there will be small change in distance only. When there is change in distance, we say there is speed. So that will be dd. Understand? So this dd by dt is nothing. It is what we call the instantaneous speed. Simple mein, you can basically write, you can remember that speed at any point is nothing but instantaneous speed. We write is basically write this. Fine. Now let's move on to basically the next one. Let's move on to the next one, that is velocity. You got the feel of average speed and average velocity? Approaching to 0. Yes, approaching to 0. That is what we call this. And if we say it like this now, delta d by delta t, or right, delta t approaching to 0, it will exactly give us dd by dt. You might have studied this in your differentiation. When we decrease this time interval at any particular point, we get the speed. That is what we call the instantaneous speed. Understand? I hope you got the feel of this one. This is the concept of differentiation. If your differentiation is weak, then this portion you will lag over here. Or simply you can just write over here, what is average speed? That is total displacement traveled, change in distance, total distance traveled, change in distance upon change in time, or total distance traveled upon total time taken. Yawar sir didn't let me take my class. Sir, sorry. Sir, at 8 o'clock, you exactly have the Love Sir's class. At 8 o'clock, you have the Love Sir's class, okay? So, I want everybody of you to join that class as well, okay? Okay, people. Let's just finish this one as soon as possible because we have to finish till 8. If not, we have to finish till 8, okay? We cannot exceed that time limit exactly. So ladies and gentlemen, boys and girls, let's basically understand what this velocity exactly is. What is the difference between velocity and speed? Now, could you please tell me one thing? This car is having the velocity of, for example, if this car is having the speed of, this is moving with a speed of, in this direction, I would say 50, or simply, or I'll just make you understand with this one. If I say, for example, this is the car over here, understand, it is having the speed of 50 km per hour, okay? Now, this car is having the speed of 50 km per hour means that how fast distance is changing with time, that's okay, we are saying the speed. Did I ask you what is the direction of this one? In which direction this car is moving? No. Now, if I ask you, this car is having the speed of 50 km per hour towards right. Towards right, we say in that case we are talking about the velocity of this car. Understand? So this is the difference between speed and velocity. In case of velocity, we talk about the direction as well. And you might have basically sir, please complete 11th as possible. I am JEE 2022 aspirant. We'll cover entire 11th 12th, man. I want everybody of you to watch every lecture, okay? Okay, now see. Now, you might have basically seen the speedometer. Why do we basically call it speedometer? Because it only tells you how fast you are going. It doesn't tell you in which direction you are going. That's why it gives you the magnitude of velocity only. And what is that other thing which is giving you the speed with the direction? That is what we call the velocity. Velocity is nothing but it is speed with the direction. Understand? Now, if I just give you the example over here, if I just give you the, everybody is understanding, drop a thumbs up. Everybody is understanding, drop a thumbs up. Okay, ladies and gentlemen. If I tell you, for example, over here, now listen to me. If I tell you, for example, over here, this is the car, okay? This is moving in the left direction with 40 km per hour. This is the another car. This is moving in the right direction with same 40 km per hour in this direction. What is the speed of this car? What is the speed of this car? You will say speed of this, if I say A, this is B. You will say speed of A is nothing but equal to speed of B. Speed of A is equal to speed of B because they are having the same magnitude, 40 km/h. Now, if I ask you what is the velocity, you will say velocity is different. Velocity of A is not equal to velocity of B because velocity, when we talk about the velocity, we talk about the direction as well. So the velocity of this is 40 km/h towards left. The velocity of this is 40 km/h towards right. Okay. Rate of change of displacement, I'll make you understand that one also, bro. Chill scenes. Everything we're gonna be talking about. Now see what actually this velocity is. Let's have a look what actually this velocity is. Chalo, let me just make you understand this velocity in detail. Okay. Now, if I tell you, I have to travel from this point to this point. I have to travel from this point to this point. Okay. Crystal clear. Okay. That's very nice. If I tell you, I have to travel from this point to this point, and I am traveling through this path. Okay. I'm asking you to tell me the speed from A point to B point. Okay. I'm asking you to tell me the speed from A point to B point. Now, right now, I'm asking you to find that speed which is having the particular direction. You will say that speed which is having the particular direction is what we call the velocity. Speed with a direction, what we call the velocity. Now, how we are supposed to find that exactly? You will simply say, if we are supposed to find the speed in this case, we'll take this distance, how much a distance it has covered. For example, if it's traveling through this path, so this is what we call the distance, and this is what we call the displacement. Okay. Now, by using the distance, by using this path, you can find the speed. But by using this path, what you will get, see, this is the special type of distance that we call the displacement. This is having the particular direction, proper direction pointing towards B. So if we take this one, can we get that kind of speed which is having the particular direction? That's what we call the velocity. Special type of speed, definitely yes. So that's why we say velocity is nothing but rate of change of displacement. So can I over here say that if we say in case of speed, that is rate of change of distance with time, so can I say over here it is nothing but rate of change of displacement? How do we represent displacement? That is S. So in order to find that kind of velocity which is having the particular direction, we can find that only by taking that path which is having the particular direction, because that will only give us the particular speed, that special speed. Understand? So can we basically say this is nothing but delta S upon delta T, and this is what we call the average velocity. 100%, this is what we call the average velocity. Everybody got this? Do let me know in the live chat if you got this one. Okay. Do let me know in the live chat if you got this one. Do let me know in the live chat if you got this one. So this is what we call the average speed from A to B, average velocity from A to B, how much your velocity is, how fast displacement is changing with time, that is what we call the average velocity from A to B. Understand? And in this case, what is the direction of this average velocity? Towards B. Fine. Now, what if I ask you to tell me the velocity at any particular point? That is what we call the instantaneous velocity. So can we basically write VINS? That is nothing but ds by dt, 100%. At any particular point, how fast displacement is changing with time. Okay. Sir, those who want to go to college and doing self-study like me, your lecture make them get more confidence to them and definitely crack JEE. Okay, make more college in shock after JEE 2022. That's very nice. Thank you. The way you explain, okay, that's very nice. Hey, you got the feel of what is velocity and what is speed. You know what is the difference between velocity and speed? This is what we call the instantaneous velocity at any particular point, how fast displacement is changing. Okay, yes, this is a vector, that is a scalar. Yeah, everybody, this is the point that basically you should know. Rate of change over here, that vector and all, scalar, speed is a scalar quantity, this is a vector quantity. Obviously, this displacement is a vector because this is having the proper direction. Okay, this is following the vector rules. So if this is the vector, displacement is vector, it's having the proper direction. That means velocity is also the vector, it's having the direction. This is the common thing, yeah. Everybody knows about this. What is the difference between average velocity and velocity? What kind of question is this exactly? Average velocity is basically from this point to this point, if you are supposed to find the velocity, understand how fast your displacement was changing with time. Understand with what rate your displacement is changing from this point to this point. In general, that is what we call the average velocity, average rate of change of displacement. That is what we call the average velocity. Understand? Like in case of speed, from this point to this point, how fast distance was changing. In general, how fast distance was changing. Or we simply say that is what we call this average velocity is nothing but it is total displacement traveled. Total displacement traveled from this point to this point is only change in distance, change in displacement, or rate of change of displacement. That's one and the same thing when we talk about from the average point of view. Total displacement traveled upon total time taken. Either you say this, either you say this. Rate of change of displacement from this point to this point. How much is the change in displacement from A to B? That is how much you have covered from A to B. That is what we call the total displacement traveled. And how much is the change in time from A to B? How much is the total time taken from A to B? That is the change in time from A to B. It's one and the same thing. Now you got the feel. Now you got the feel. Yes, you will get the... I'll show you the questions itself over here. Okay, average speed we say total distance traveled from A to B. Average velocity we say from total displacement traveled from A to B. Understand? And what is instantaneous velocity at any particular point? How fast displacement is changing with time. Understand? Chalo, let's move. Could you please tell me in this question what is the distance, displacement, average velocity? All of you, I want everybody of you to, now we have the questions, we have to solve the questions. I want everybody of you to solve this one. Yeah, any confusion you have? Super understanding, sir. Any sort of confusion you have, do let me know right now, okay? We are about to finish this lecture. We'll solve 7, 8 numericals. Any sort of confusion you have, do let me know right now in the live chat. Come on. If not, drop a thumbs up. Come on, man. Zindagi aur. Come on, I want everybody of you to solve this. Give me the answer of this one. Everybody, how you are supposed to solve this one. A body is traveling from A point to B point. This is the path. This is the actual path traveled. You are supposed to tell me distance, displacement, average velocity. This was actually asked in some JEE. I don't remember the date exactly. Thank you for your hard work, sir. You have to do the hard work, okay? That is the main point. My hard work doesn't matter. What matters is your hard work. Displacement and distance when it is equal. Arey bola tha na yaar. I told you. When you travel from this point to this point. Understand? So this is the actual path. In this case, displacement is this, distance is this. I hope you're asking this only. Not sure what you are asking about. Come on, I want you people to solve this one. Because that is the rule and that is the protocol. Okay? Okay, a lot of people are writing the answers in the live chat. Let me just solve. What is the distance? That is the actual path covered. That is how much this one, okay? This is half of the circumference. Okay, what is the full circumference? Can I say this is the full circumference? And what is circumference of a circle equal? Circumference equal in this case. So can we say that is nothing but 2 pi r is the entire circumference. But this is only half, so it will be 2. 2 cancel. So it will be nothing but pi r. What is the value of r over here? That is the radius is 1 meter. So this will be pi into 1. It will be pi. So what is the value of this distance? Kidhar chala मैं? So what is the value of this distance? Can I basically say this is nothing but pi? Everybody got this one? And what is the value of displacement? That is how much you have displaced from original position, initial position to the from the initial position. That is this much. So how much is this? This is 1 meters radius and total diameter is 2 meters. So this is 1 plus 1, that is 2 meters. So this will be 2 meters. Just write 2 meters. And what is average velocity? What is average velocity? In general, A point to B point, how much is the change in displacement, or how much is the total displacement traveled upon total time taken? अरे बोला था ना, VAVG is nothing but delta D delta S by delta T. Change in displacement upon change in time, or total displacement upon total time taken. It's one and the same thing. So can we say VAVG is nothing but total displacement traveled from on A to B? That is 1 plus 1, that is 2. And total time taken, it's saying in 1 second it has covered the entire journey. So it will be nothing but 2. Everybody understood this one? Drop a like. Sir, no Hindi. Sorry. Sir, your bola tha na yaar was amazing. Okay, that's very nice. Thank you. Chalo, let's move on to the next question. I'm increasing the level of the questions. Okay, that's why I told you in the beginning itself, this is the level up series. I want you people to, the displacement of a body is changing. The displacement time relation is given over here. You are supposed to tell me the average velocity from 0 to 2 seconds and instantaneous velocity at t is equal to 5 seconds. Let me just make you understand this question with the real life feel. This car is moving in the forward direction. Fine. This car is moving in the forward direction. For example, I say in this direction, not forward, backward, in this direction. Okay. Okay. This car is moving like this. I'm saying that its displacement is changing with time. The relation is given over here. The relation, exact displacement is not given 30 meter, 40 meter, 50 meter. It is given in terms of this equation. Displacement is changing with time. Understand? So different times, it will have different displacement. That is what we are supposed to find over here. No, we are supposed to find the velocity. Okay. So he is asking us to find the average velocity from 0 to 2 seconds. For example, this is 0 seconds and this will be 2 seconds. From 0 to 2 seconds, what is the average velocity? Understand? And he is asking us to find the instantaneous velocity at t is equal to 5 seconds. So t is equal to 5 seconds, t is equal to 2 seconds, t is equal to 0 seconds. Understand? On these time intervals, at this time interval, we are supposed to find the instantaneous velocity. And from a 0 to 2 seconds, when the car was traveling, from 0 to 2 seconds, we are supposed to find the average velocity. Tell me, how do we find this? Bolo, can you guys solve this question at your own? Come on. Okay, let me just show you. See, if we are supposed to find the instantaneous velocity, how do we do this? That is ds by dt. Previously, I told you rate of change of displacement with time at that particular point of time. See, he is asking us to find at this point. That means at this point, we are supposed to find that will be ds by dt. Means at this point, we have to find how fast displacement is changing with time. That will give us the velocity at this point. So how do we exactly do that? We have to differentiate this equation. So how do we do that? VINST. So how do we do this? We need to differentiate this one, then only we will get this one, because velocity is nothing but differentiation of this displacement. Everybody is understanding? Somebody is saying integration. How integration, man? Our displacement is given. We are supposed to find the velocity. We have to differentiate, not integrate. He deleted that. Sambhav Kumar, it's okay, man. Chill. It's okay. Can you explain again? Yeah, this is very simple, man. Okay, next question. We are on the same. We have on this concept only. Now, differentiate this one. How do we differentiate? I hope you know how to differentiate. So this will be nothing but 2 into 2. That will be 4t plus 4. The differentiation of this is nothing but 4t. Differentiation of this is 4. How? Power down, power minus 1. That is 2 into 2. That is 4t. T raised power 2 minus 1, that is 1. That is 4t minus, and this will be 4. I hope you know how to integrate. Now, we got the velocity at t is equal to, we don't know. We got the instantaneous velocity. That is this one, 4t plus 4. Now, we are supposed to find at t is equal to 5 seconds. Put the 5 over here. At instead of t, I'll write 5 plus 4. How much? This will be 24 meter per second. Everybody got this one? Everybody got this one? Yes, Harsh. Hari, H-A-R-I, H-A-R-A. Hari Harashudan. Sorry, man, I'm not able to pronunciate your name. Okay, now, let's solve the next question. Let's solve the next question. Okay, we are supposed to find the average velocity from 0 to... We are supposed to find the average velocity from 0 to 2 seconds. Chalo, average velocity. How we find the average velocity? That is nothing but total displacement traveled. Total displacement traveled upon total time taken. Understand? Total displacement traveled upon total time taken. How much is the total displacement traveled? Can I write that is, this is nothing but delta S by delta T. It is nothing but S2 minus S1 upon T2 minus T1. I want in the same thing, man. Okay. So this is what? S2 minus S1. Final point minus initial point. If I talk about that, अरे यार ये तो पीछे हो जाएगा. चलो इधर ही दिखाता हूँ. अब फिर से इधर गया. अच्छा खत्म हो गया ये. चलो. I'll just wrap this over here. No. You need to take the notes from this one. Na? Okay, chalo, I'll show you over here. I'll just show you over here. Everybody is understanding bus one. VAVG is nothing but S2 minus S1 upon T2 minus T1. That is from 0 to 2 seconds you are supposed to find average velocity. From 0 to 2 seconds you are supposed to find the average velocity. And at S2, basically at T is equal to 2 seconds, you are supposed to find what? How much a displacement you have covered. At T is equal to 0, you are supposed to find how much a displacement you have covered. 1 second, I need to message this one. Okay, fine. Now see. We are supposed to find this S2. We got done with this one. How we are supposed to find this S2? At T is equal to 2 seconds, we have to find the displacement. So that will be nothing but S2 is a nothing but. So that will be nothing but T. And this will be 2 square plus this will be 4 into 2. Understand? At T is equal to 2 seconds. So we got this one. S2 is a nothing but. This will be nothing but. This will be 8 plus 8, it will be nothing but 16. And what is the value of S1? S1 will be nothing but 0, because at T is equal to 0, how much displacement it has covered? 0 displacement, because the car was exactly at the origin at that point of time. So can we put this over here? This will be nothing but 16 minus, it will be 0 upon T2 minus T1, that is 2 minus 0, it will be nothing but 8 meter per second is the average velocity. Everybody got this one? I'll show you this in the next class once more, because we have got lots and lots of questions. I want you people to solve these questions at your own, because we got Love Sir's class is at 8 o'clock. So I have to basically finish this one. This is the next question. The displacement time relation is given this one. I want you to take the screenshot of this one and solve this. And in next class, and solve this question. Do let me know the answer of this question in the comments down below. Okay. This one is given. Fine. Displacement time relation is given. Average velocity from 0 to 2. This one. At T is equal to 3 instantaneous velocity. Velocity is given. You are supposed to tell me displacement covered from 0 to 4 seconds. Next question. Average velocity. If body travels from this point to this point, half of the distance with V1, half of the distance with V2, you are supposed to tell me the average velocity. Next question. On the same pattern, you are supposed to tell me the average velocity. Next question. V is equal to 60 square plus T, find displacement time relation. Okay, velocity time relation is given. You are supposed to tell me the displacement time relation. I'll show you all of these questions in the next class. Okay, so chill scenes, no need to worry about anything. Chill. Okay. Now we guys need to leave. I need to leave because Love Sir's class at 8 o'clock. So I want you people to join that class as well. And I want everybody of you to do let me know in the comments down below if you want my class in the morning session, okay? So that you won't get tired. Do let me know if you want my class in the morning session, that in the comments, okay? And once we get done with the lecture, please comment down below what was the exciting part and what do you love about this session. That's all. And share this with your friends. Okay. Now, ladies and gentlemen, I need to leave. So, We have this plus platform, we have this Iconic platform. Understand? You can take this Iconic subscription, you can take this Iconic plus subscription, Iconic subscription. In plus subscription, we have live classes, weekly tests, unlimited access, structured courses. And in Iconic subscription, we have personal guidance, we have test analysis, we have experts guidelines, study material, and study planners. Okay, then you can follow me on Unacademy. This is my username. If you need any sort of clarification, you can definitely contact me over there. And this is the IIT JEE Iconic subscription offer right now that's going on. You can get the brand new notes that will be delivered to you if you take 12-month Iconic subscription, 18-month, and 24-month. Okay, then we have this plus subscription offer. If you take plus subscription for 12 months, you'll be getting 2 months extension. If you get plus subscription for 24 months, you'll be getting 2 months extension. And for plus subscription 12 months, you can take this plus subscription for 12 months, 18 months, 24 months. For 18 months, the price is this. For 18 months, the price is this. For 24 months, the price is this. By using my code, you can get the maximum possible discount. By using my code, you can get the maximum possible discount. By using my code, you can definitely get the maximum possible discount. No, sir, morning online class. I'll create the poll for this one. Okay, don't worry about that. And then we have on plus subscription, you can take Iconic for 12 months, 18 months, 24 months. The prices are listed over here. The prices are listed over here. It's given over here. By using my code, you can definitely get the maximum possible discount. I want you people to use my code only. Okay, if you allow me, use this one and this one. Finally, fine. And then we have, these are the few of the batches which are running in Unacademy right now. You can take any of the subscription if you want to boost your rank, if you want to increase your score, okay, in your IIT JEE. At the end, I am saying thank you to everybody of you. Share this video, subscribe to this channel, press the bell notification, because this will give you the update whenever we come live. Once I end this live stream, I want everybody of you to comment down below what was the exciting part, okay? That is mandatory. And do let me know what is the answer of the question in the comments down below. Thank you so much. Like, share, and subscribe. Before I leave, like this video. Thank you so much. See you tomorrow. Bye-bye. Have a good day. And watch the Love Search class. He is coming, okay?